back to what's the relationship. These are not the same. That's left over from the previous taping. We're not quite up to Price is Right production values. So what's the relationship between these two molecules? Again, first thing you want to ask, are they isomers of any kind? Do the molecular formula. 1, 2, 3, 4, 5 carbons on the left. 1, 2, 3, 4, 5 carbons on the right. 1 unsaturation in both molecules. All right, a ring is an unsaturation. Bromine, oxygen, bromine, oxygen. Okay, all the carbon, same number of carbons, same number of heteroatoms, same heteroatoms, 1 unsaturation in each. They're isomers of some sort. So go away and figure out what kind of isomers they are. All right, so are they superimposable? You might think I've drawn mirror images. They're not quite mirror images. Right? If that's a mirror plane, it's drawn almost like a mirror image, except in a mirror, the bromine back would be a bromine back there. So you're not going to have a bromine back in the mirror switch sides. All right, so they're not mirror images. If they're not mirror images, they are not enantiomers. All right, this means not. The X means not. Are they connected the same? 5-membered ring, OH on a carbon adjacent to a carbon with a bromine, 5-membered ring with an OH on a carbon adjacent to a carbon with a bromine. So they're connected the same. All right, they're not constitutional isomers. They're not isomers. Are they the same? Can I overlay them? Is there any way to do that? So to get the 5-membered ring and the Br and the OH to overlap, I'd have to pick this molecule up, turn it over, slide it over, and that looks like it would come close, except if I do that, let's turn this one over. All right, so when I pick this up and turn it over, the bromine will be back, sure enough. The OH that's out, though, will be back. Oh, that's too bad. That structure doesn't superimpose here. I can slide it over, and in 2 dimensions they fit, but the OH is back in one, the OH is out in the other. And so you've probably worked this out already. This is a trans relationship between OH and Br. This is a cis relationship. So they're not the same. They're not conformational. They're pretty much these diastereomers. It's a cis-trans relationship. So indeed, that's a diastereomer. Those two are diastereomers.